Okay, this is the second part of Chapter 2, Section 1. If you watched the first video, and you should have, you saw that we talked about angles and how we measure angles with degrees and more mathematically with what's known as radians. So once again, if we have the vertex at the center of the circle, so all we're doing now is we're gonna, instead of saying we're on an XY axis, we're gonna actually be looking at a circle. Then the distance from the vertex to the circle, we already know what that is, right? That's radian. So if I have a circle that goes out 3, my radius of 3, then that's how I could actually find radians. So radians just simply means how far from the vertex I am to the circle. So if I want to measure arc length, so arc length is this length here, like this S. And so if you can probably guess, is it would tell me if there's, say, a particle traveling on a circular motion. And in this case, I can find that measurement by this formula. So arc length says S, arc length, take the radius and multiply it by the angle. Okay, so the angle between. Now the big key here, and I see students make mistakes in this all the time, so put a big star, do not mess up that word radians. So when you do these, you have to change, and we'll see here in a minute how to change degrees into radians. Let's actually look at this a little bit. Get me a pen going here. So if I have this arc length circle over here, trying to get my pen to work, and if I remember kind of back in my geometry days, is the ratios of my angles equal the ratios of my arc length. Okay, so that length, and once again the arc length is that distance right there. And so what I could do then is, well, I have angle theta and angle theta 1, so I could write the ratio of the angles, and then I have my arc length of S, and then I have my other one here of S1. All right, so we're just saying the ratio of the angles, I just noticed that. I probably will do that a lot. We like angels. And so I set my ratio of my angles equal to the ratio of my arc length. Well, let's suppose that theta 1 is 1 radian. Okay, so let's just suppose, remember we talked about difference with degrees and we're moving to radians. So if theta 1 is 1 radian, then by the definition, my S1 would equal 1 radian, because hence the radius. So what I can do is I can take the formula that I just wrote, the ratios above, and say, well, theta over 1 radian equals S over my radius, which is R. Or if I solve this for S, meaning I multiply R on both sides, I get my formula. So once again, this is the formula for arc length. So if you're given some information of an angle and then the radius, you simply plug these two in, and please don't forget your angle needs to be in radians. All right, so let's kind of look at some of these. So it says find the length of a circle of radius 2 meters subtended by a central angle of 0.25 radian. Well, to find arc length, we just said that it's S equals R theta my R is 2 meters, and my angle is actually already in radians, okay, and so this was meters. And so if I multiply, I get 0.5 meters. All right, if I have the minute hand of a clock is 3 inches, how far does the tip of the minute hand move in 20 minutes? So let's get us a clock here. It says the minute hand of the clock is 3 inches long. So let's just simply say that here's my minute hand, which is 3 inches. How far does the tip of the minute hand move in 20 minutes? So it doesn't really matter where you put the starting value. I started it because we've been showing all of these with the standard position, with the vertex in the middle. So if I go 20 minutes, I know if I go 15, I just draw a line straight down. So 20 minutes will probably be a little bit over here. So that's saying I moved in 20 minutes. And it wants to know how far does the tip of the minute hand move. So going back to the definitions I know 1 revolution is 360 degrees, okay, all the way around. We're going to have it coming up here, but the definition of 360 degrees in radians is 2 pi, okay, again, definition. I'm going to talk about this more here in a minute. And so what I could do is I could say, well, we're talking about a clock. 1 revolution is all the way around, which is 60 minutes. And my length, the minute hand, is 3 inches. So I'm actually going to divide that by 3. Well, I do the same thing over here. I divide this by 3. You do something to one side, you have to do it to the other side. So if you notice what happens, this gives me my 20 clock minutes that it moved, 20 minutes. And if I put this in a calculator, I get 2.094 radians. All right, so what I wanted to do is I wanted to match and get this in terms of 20 minutes, which I did. When you do something to one side, you have to do it to the other side. And now I have my angle in radians. I'm not finished because I'm just now to where I can use my formula. So my formula, my radius is 3, and that was in inches. And we just found the angle, 2.094 radians. And if you stick that in your calculator, you should get something like 6.283 inches. So again, the key is, and you can pretty much on these with the clock start at the 60 minutes, but then divide by whatever value you need to turn this in to match the 20 minutes and to get this in radians. Okay, so as I mentioned, we're going to I kind of just threw that definition in there that 360 degrees is the same as 2 pi. Well, let's see why that is. So if I want to convert, if I'm looking at converting degrees to radians, so if I have a circle, maybe I'll get better at drawing circles here, and I'm going to put my ray right there. If I go all the way around, what this is the circumference of a circle. If I travel all the way around that circle, that's what I'm doing, is I'm going around the circumference of a circle, which, if you remember, the formula is 2 pi r. So the circumference of a circle, 2 pi r. If I say, well, let's call this S, okay, because we just said if you go all the way around it, I'm doing my arc length, which is S. So we said S equals R theta. Where I see an S, I'm going to plug in my 2 pi R theta. I can divide both sides by R. So this is how I get 2 pi. So in other words, therefore, 1 revolution equals 2 pi radians, which also equals 360 degrees. Okay, so and you're going to see from now, you're just going to kind of memorize this. All right, but this was how you come up with it, is if you're looking at the circumference of a circle, you're saying you're going all the way around it. Well, what is that arc length? And that's what we're finding here. And as we can see, the radiuses cancel and we get the theta, which remember is our angle, is 2 pi. So that tells me 360 degrees, 1 revolution in radians is 2 pi. If I have something like, so I said 1 revolution is 2 pi radians. All right. Well, what if I take and divide both sides by 2? So half of a revolution, if I divide 2 pi by 2, would be pi radians. So if I go halfway, which might be helpful to go ahead and put the degrees, since most of us think more in degrees. Half of a revolution, I'd be at 180 degrees. So if I'm looking at this and I say, well, then 180 degrees is pi radians, then I can take this 180 equals pi, and I can divide both sides by 180. And what this gives me is it says 1 degree is equal to pi over 180 radians. So what you use this for is converting from degrees to radians. And of course you can do the same thing going back the other way. If I want to go from radians, so 1 radian is going to be the same thing as 180 degrees over pi. Okay, so in other words, I just took this right here, divided both sides by pi, and these are my 2 big definitions. So this is to convert from radians to degrees, and this is to convert from degrees to radians. And so you'll kind of see this summarized here. 1 revolution all the way around, 2 pi radians, 180 degrees, pi, and then 1 degree, pi over 180, or 1 radian, 180 over pi. How I kind of remember these is if I'm going from degrees to radians, the pi's on top. If I'm going to radians to degrees, the pi's on the bottom, because you're going to have a pi in there that you're going to cancel out. And that's just how I remember those. So if I want to convert, I want to take and convert, these are in degrees. Now be careful, because I have been known to trick students. If I write 60, that's radians. Because if you do not see that little degree symbol, it's radians. Okay, so remember that. Well, these of course are in degrees. So to convert, I take and I'm going to radians, 60 degrees. As I mentioned, the pi goes up top. And so I get 60 goes into 180 3 times. So pi over 3 radians. All right, same thing for negative 45 degrees. Negative 45 degrees times pi over 180. Believe it or not, 45 times 4. So 45 goes into 180 4 times. I get, and remember we can have negative angles. We're just going clockwise. and I get negative pi over 4 radians. So that's the big key when you're going from degrees to radians. Well, of course, you can go from radians to degrees. How do you do that? As I mentioned, you're going to multiply by 180 over pi, because the pi's will end up canceling. And again, that's how I always remember which one do I use for which, is I need to cancel the pi's. 6 goes into 180 30 times, so 30 degrees. Same thing here, 180 over pi. The pi's cancel. 2 goes into 180 90 times, so I get 270 degrees. All right, and a lot of times you'll find tables that will show this of commonly encountered angles. And so as you can see, the one we did was, well, we did negative, but the 45 degrees, what other one did we do? We did the 30 degrees. So you can see these in here, but you should be able, as practice, you should be able to convert every one of these degrees into radians and then be able to go back and convert the radians into degrees. So you should be able to do that. All right, so we know how to go from radians to degrees and degrees to radians. Again, the important part is typically a lot of your problems, they're going to give you the angle in degrees and you're going to have to convert it to radians. All right, this next piece here talks about the area of a sector. What we did before was the arc length, so that was that distance here. Now I want to know this area in here. Okay, maybe it's a patch of grass that I need to know, or putting flooring down, and I need to know what this area is. So if I go back to that whole deal that I mentioned of ratios, that the ratios of the angles are also equal to the ratios of the areas. Okay, so just like the arc length one. So once again, let's suppose theta 1 is going all the way around. It's the entire area, okay, 2 pi all the way around. And so then area 1 would be the area of a circle, which is pi r squared, right? If you go all the way around, and I want to know the area, all the way around is the area of the circle. So coming back and repeating this now, where I see theta 1, I put 2 pi. Where I see a1, I put pi r squared. If I solve this for a, because that's what I want to do, I want to find the area. Notice that this whole piece goes up top, so I'm going to have theta pi r squared over 2 pi equals a. And the pi's, of course, cancel. And typically, and that's it, that's solved for a, but typically you will see the 1/2 brought out front because the 2's on the bottom. And then what's left over is theta r squared. This is the formula for the area of a circle. Once again, my theta, my angle, has to be measured in radians. Okay, so that's important, and that's what this says. So the 1/2, I just switched around, r squared theta. So I have to remember that my angle has to be measured in radians. So you typically see problems like this as a water sprinkler sprays water over a distance of 20 feet. So I have this lovely little sprinkler here, sprinkling water. Be sure and do sound effects when you do math, it helps. And it's spreading out here a distance of 20 feet. And it says while rotating an angle of 150 degrees. So I don't know, that's probably about 150 degrees. So there's my angle. Now what I want to know is what is the area of the lawn that's receiving water based on this information. Well, I use my formula, A equals 1/2 r squared theta. A equals 1/2, r is 20, squared. Theta, better be careful, it's 150 degrees degrees, but it needs to be in radians. So you multiply it times pi over 180. Okay, so that's the big key. And so I can write all that down here, 150 times pi over 180. And I stick all that in my calculator, and I get approximately 523.60 square feet. Let's go. And so that's probably the biggest trick of these. You know, students always say stuff to confuse you, but that's what I see a lot with students, is making the mistake and not remembering to change it in the angle into radians. All right, we'll just have a small section for part 3, but let's stop right here, take a breather, practice these.